angles. Why did it change colors like that? Why do I ever know? I don't ever know. So here's a quick example, and then we'll do some other problems just to practice. So, for example, 30 degrees and 390 degrees are coterminal. Let's think about what those two angles look like. That is not what I planned to have for my graph. There it is. So a 30-degree angle would be about there, right? Now, if I do a 390-degree angle, that simply means I start at my positive x-axis, I go all the way around to 360, plus an additional 30. How does this angle compare to that angle? It's basically the same angle on the graph, right? But it has two different names. So 30 and 390 are both coterminal. If we wanted to, we could actually subtract 360 and find another one. Add or subtract 360, or 2 pi if they're radians, to find coterminal angles. Okay, so those are instructions. So like if we had 30 degrees, then adding 360 gives us 390. What if we add 360 again? Would that also be a coterminal angle? I don't know if I want to add them. Let me see. 5, carry the 1, 750. Or we could subtract 360 and find coterminal angles that way. So negative 330 degrees is also coterminal with these angles. It's basically the same angle, it's just we draw it differently. Oops, that line is a little crooked. So doing negative 330 would mean that we're going clear around 330 degrees to that 30-degree angle. So it's still the same angle, it's just getting to it a different direction. Not that that really matters for the end result, but it's just something to be aware of, that we have infinitely many angles that land in that same place because we can add and subtract 360 infinitely many times. Okay, let's look at the examples from the book. Graph each of the oriented angles in standard position and classify them according to where their terminal side lies, meaning which quadrant of the coordinate plane or which axis if quadrantal. Then find 3 coterminal angles, at least one of which is positive and one of which is negative, for each of the angles. So we're finding 3 coterminal angles. So let's underline all the information we're finding here. We're finding 3 coterminal angles. We're graphing the oriented angle in standard position. We're telling what quadrant it lies in or which axis if it's quadrantal. Right? Okay, so I'm going to draw my angle. Here, and I'm approximating where it would be about there. I didn't line things up perfectly right, but it's close. Okay, So 60 degrees. So what quadrant is 60 degrees in? Do you remember your quadrants? This is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. So this particular angle, the terminal side, lands in quadrant 1. It's a quadrant 1 angle. Let's give some coterminal angles for 360. So to do that, we could add 360 and get what? What would we get if we add 360? Did I add right? I'm suspicious of my ability to add and subtract today. Especially when I keep getting numbers like 69 and 420. It makes me wonder if I'm doing something wrong. Or if someone purposely wrote these problems into this textbook. No, it wasn't me. This textbook is actually based on a different open source textbook that was that we tried using a few years ago, and it just ended up being a really confusing, heavy textbook. Like, not heavy, physically heavy, but just like really heavy reading, really hard to wade through. And so that's when one of the math professors at Salt Lake Community College took it on herself to try and rewrite it. Because an open source textbook means it's not copyrighted. It means somebody wrote this textbook, and so it's not copyrighted, so someone else can take that textbook and change it and rewrite it, which is what Salt Lake Community College is doing in partnership with the University of Utah and Weber State University. So I actually am on this committee of professors from these different colleges that we've been working on this for several years to write it, rewrite it, edit it, find, and I don't do much really. I sit in on the committee meetings, and that's what I have that's conflicting on Fridays actually with when we can hold our Friday classes. Then I just contribute ideas pertaining to kind of more of the high school culture and how I feel about the problems and how they would pertain to you guys. So I'm a voice in that for this textbook. So, okay. So we have our 60 plus 360. I think it's 420 if I did that right. And then 60 minus 360, so that would be negative 300. Does that sound correct? Did anyone take it further than that? You could either add another 360 or subtract another one. Well, that would be 300 minus 360. So negative 660. So there, we got 3 coterminal angles. But how many are there? How many different possibilities are there? Infinitely many. We just keep adding 360 or subtracting 360. It never ends. Okay. I hope you're moving on without me and trying these on your own, because then I can just kind of barrel through. So here's angle beta, negative 225. So I'm going to count around. There's 90. There's 180. There's 270. Oh, that's too far. So halfway between 180 and 270. This is the angle I multiplied incorrectly earlier when I got like negative 135 and it was actually negative 225. So this is that exact same angle from that problem. All right. So let's go ahead and name the quadrant. What quadrant is that one in? It's actually 2. Let's review our quadrants really fast. So I'm just going to write on the top of this stuff here. So we have quadrant 1, quadrant 2. We start with quadrant 1 where all the numbers are positive, positive, and we go counterclockwise. Quadrant 3, and we use Roman numerals. And quadrant 4. Sound familiar? So this one is quadrant 2, correct? Okay, so then we would add and subtract 360. And we get 135. Oh, well, there's the 135 I somehow got before. Or we could subtract it. You guys tell me what you're getting so that we can hurry this up a bit. And then you need one more by like adding or subtracting 360. 490? Shouldn't it have a 495? Now you're good. Okay, now we need to do the same thing with radians. That sounds scary. Okay, 9 pi fourths. Instead of changing it to degrees and then adding or subtracting 360, might as well just stick with radians and add or subtract 2 pi, right? But now we have to use fractions. Let's go ahead and sketch this. That's probably the scary part to start with, is sketching it. So 9 pi fourths, we're going to start here. So pi fourths would be, remember that if we go straight across, that's half. No, that's a whole pi, correct? Because the whole thing is 2 pi. So this is pi over here. So this would be pi halves. So pi fourths would be in here. But we're not doing just pi fourths, we're doing 9 of them. So 9 pi fourths. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, guess what? It went all the way around and then some. So 9 pi fourths ends up being in quadrant 1, just because it went all the way around first before it cut there. Okay, so now let's find some coterminal angles. So 9 pi fourths plus 2 pi. Well, if we're going to add 2 pi to something with fourths in it, that means we actually need to change our 2 pi to 8 pi fourths, correct? So 8 pi fourths. So that would give us 17 pi fourths. Or we could subtract 8 pi fourths. And that would give us pi fourths. We need at least one that's negative, so we should probably subtract again. So then negative 7 pi fourths. So there's 3 coterminal angles, I think, or did I only do 2? Oh no, there's the third one. 3 coterminal angles, at least one positive, at least one negative. I left them all in radians, which means I had to deal with fractions. That's all right. Okay, last one. We've just got a couple of minutes here. Why don't you guys, well, here, I'll help you sketch it, and then I'll let you find the radians on your own. You can just tell me what you figured out. Okay, so negative 5 pi halves. So pi halves is 90 degrees. So that would be 1, 2, 3, 4, 5. This one's a quadrantal angle. This one is on the negative y-axis. Instead of in a quadrant. Okay, go ahead and find some coterminal angles for that one. Just yell them out. Let's see, did you add 4 pi halves? Awesome. Add 4 pi halves again. Yeah. Okay, and then we could either subtract or add again. We could just add again. Or we could subtract. So 7 pi halves. Or if you subtracted, it would be what? Negative 9 pi halves. All right, hopefully you've got the general idea. Did that match up with our notes? Is that everything?